Okay, we're live. Hello, everyone, and welcome to the Chainlink CCIP workshop. So, it's a part of the Polygon DevX India workshop series, and we are super happy to kick off the Polygon DevX India tour, the India Hackathon on DoraHacks.io. Polygon and all other partners and sponsors have been on a roll. Did super successful hackathons, a plethora of builds flowed in. I can already see a lot of builds flowing in for the India hackathon as well. I have with me Frank today. Hey, Frank. Frank is a developer advocate from Chainlink, and he's going to talk about Chainlink CCIP, which would be very helpful for the builders building in the course of the hackathon. So yeah, Frank, I'll pass it on to you. If you have any opening thoughts, feel free to throw some light on that, and then let's go with the content of the workshop.
Oh yeah, thank you, Mishika, and I'm really excited to be here. And yeah, this is my first time to give a workshop in Indian developer community. And let me just briefly introduce myself, and I can just move to my content. So my name is Frank, and I am a developer advocate in Chainlink Labs. And the main job for me is to reach as many developers as possible and to tell them there is something called a Chainlink, something called Oracle, and through the Oracle, you can combine the Web2 data and services with the Web3 smart contract. So by doing this, you can just extend your smart contract to a hybrid smart contract, which means you can not only handle the data on chain, but also handle the data and the logics off chain. So today I'm going to give you a theoretical content of the Chainlink and also give a coding part. So if you have your laptop with you, I strongly encourage you to code with me. And if you can complete this demo on the workshop, I will give everyone a NFT. And yeah, let's start.
Okay. Yes, let's start. Also, everyone who's watching, if you have any question or doubts during the workshop, feel free to put it in the chat. We'll take it after we're done with the content of the workshop.
Okay, so let me just share my slides. Okay, so in today's workshop, I'm really excited and I'm going to introduce three sessions. So in the first session, I'm going to introduce what is an Oracle problem and how we can solve this Oracle problem with the infrastructure provided by Chainlink. And in the session two, I'm going to give a very brief introduction about the Chainlink DON, which means decentralized Oracle network, and the services based on this network. And then I'm going to give a demo about using the Chainlink CCIP to build a cross-chain NFT. So in this demo, we will build a USC 721 smart contract, and we will just send a message from the source chain to the destination chain, and then we can get a new NFT minted on the destination chain. And that is very easy because we leverage on the Chainlink CCIP and we can complete that in 20 minutes. And in the last part, I'm going to introduce some resources that the developers can reach in the Chainlink developer community. When you have some technical questions or you want to get some marketing source or what you want to participate in the hackathon, you can find this kind of stuff in our developer community. Okay, so let's start. Let's start from the answering question, what is an Oracle problem? So simply put, the Oracle problem is like the problem that to describe that a smart contract on the blockchain is not able to proactively to fetch any data and services from the Web2 world. So the reason of this is that it's because the blockchain is a deterministic system, and in the deterministic system, we can only handle the transactions like 1+1, and no matter when, no matter who to execute the result of the 1+1, the result will always be 2. But if you want to just get something from the Web2 world, want to call an API to get some temperature data, transportation data, or you want to build a application and put the logic layer on the Web2 and put the asset layer on the Web3. If you want to make these two layers interact with each other, you just cannot do that because that is called a indeterminate transaction. The reason of that is every single piece of the data on the blockchain has its own ownership, right? So that means there is not a central authority that can remove, update, or alter data arbitrarily. Every time if anyone wants to update the status on the blockchain, this guy need to make a proposal and broadcast this proposal to the whole network of this blockchain. And every different node under this network need to just learn what is described on the proposal and execute this transaction to see if they can get the same result. If they can get the same result, they can reach the consensus and the data can be updated on the blockchain. But if they want to get some data from the Web2 world, maybe different people will get different answers. If they want to get a random number, maybe different person will get a different number, right? So for this kind of indeterministic transaction, that cannot be handled on the blockchain. So you just cannot update the data and go through the consensus. So the solution or the answer to solve this Oracle problem that we need to rely on some third-party services or third-party agency to help us to build a infrastructure to relay the data or other services from the Web2 or from other blockchain to our blockchain. And by this way, our smart contract can send a request to the infrastructure. And this kind of the infrastructure will, based on our request and execute what they ask them to execute, get data or do some computation and relay or feed this result back to the smart contract we deployed on the Web3. Okay, so when the concept of the Oracle, when this concept was firstly introduced in this industry in the very early stage, it's quite straightforward. We just call this the centralized node a Oracle, and we will write some script in our server. We also call it an Oracle node, and then this Oracle node will just keep keep monitoring the status of the decentralized network, like Ethereum, like BNB chain, like Arbitrum or other layer 2. And if you update the status of this smart contract, like you send an emit or you change some variable on the smart contract, this will be regarded as a request. And if this is detected, the centralized node off-chain will just get this request and execute the script deployed on this server and get the data from its own data sources. And if this data can be successfully fetched by the data sources, the centralized node, or we can call it Oracle node, will feed this data back to the decentralized Oracle network. So by this way, your smart contract can just interact with the real world, interact with like a temperature, like a RWA, like a gaming, anything you want. You can get this kind of data from the off-chain world. Sounds good, right? But here is a problem called a single point of failure. So think about it. The whole reason we want to build our application, and we call it a decentralized application on the blockchain, is that we want to rely on the thousands of or at least hundreds of nodes of this decentralized network to promise that the status of our smart contract cannot be updated or altered or removed by a central agency. And we, by doing this, we can bear with a high transaction fee and we can bear with a latency problem. But if we get a single point of failure by connecting the data to the outside world, we will compromise the security of the whole system. So if this Oracle node is attacked, or is exploited by some malicious actor, or the centralized node do some transactions maliciously, then the data can be controlled by a party. And the protocol based on the decentralized network will receive the wrong data. And the money of your user may be lost, and you will just make the whole system meaningless. You just compromise the security of this whole system, right? So the solution for this single point of failure is that we can build a infrastructure called a decentralized Oracle network. We also call it DON. And compared to the centralized Oracle network, we will have a group of the Oracle node under a network, and we call this network as a decentralized Oracle network, the DON. And every time, if the status of the smart contract is updated by some requester, and the DON, one of the nodes in this DON will detect this request, and then every node under this network will go and reach out and get the data from its own data sources. And after the data is fetched by the different nodes under this DON, and they will talk to each other and do something like a consensus, but we call it aggregation. They will just calculate the median value of all the results fetched by the nodes under this network, and then aggregate these results into a final report. And in the last step, this network will submit this final report back to the decentralized network. And on the decentralized network, like Ethereum, we can use the smart contract to do some verification of this report to see like if this result under this report is submitted as a correct node, correct address. And if the necessary verification is done, and if this result is legal, this data can be saved on the smart contract. And your smart contract, I mean the consumer smart contract, is able to consume this kind of data from the Oracle smart contract. And by this way, we kind of mimic the trust minimized feature on the decentralized network in our Oracle layer, or we can call it data delivery layer. So if in this scenario, if someone wants to control the data provided by the Oracle, it is very hard for him to just control every node under this network. So this is secure and safe for the people, for the developers on the decentralized network to fetch some data in the off-chain world. Okay, so the Chainlink is actually a decentralized Oracle network. So in the Chainlink lab, we maintain and develop a software for the decentralized Oracle network, and we have a lot of the different node operators to operate our Oracle node. And based on this decentralized Oracle network, we provide some Web3 services like a data service, computing service, and a cross-chain service. So in today's workshop, I'm going to first introduce the data services, because I want everyone to understand what is a DON and how this DON to help to secure the data fetched from the off-chain world to the on-chain world. And with the basic understanding of the DON, we can move to the cross-chain. And this is also the focus of the tonight workshop, your CCIP. So in the CCIP, we actually have different infrastructures. We have two DAOs and one something called RMA, and to promise that the whole process is decentralized and secure. So first, I'm going to introduce the first service under the Chainlink data services, the data feed. And maybe everyone, if you want to build something like a decentralized finance, the DeFi, there is a very, very decent chance for you to employ the data feed to help you to get the correct data from the off-chain world. And this is the workflow of the data feed. So like we said before, we have a DON, the decentralized Oracle network, running off-chain. And this DON will just go and reach out a data source through a data providers and get the price data from these data providers. And then they will just go to aggregate all these results and talk to each other. And if they can get the final report, they will finally transmit or submit this final report containing all the results fetched by each node under this network to the on-chain smart contract. So we have a smart contract called an aggregator contract. This aggregator contract is used to verify if every price data in the report is submitted by the correct node by verifying the address and the signatures. So if this result is verified successfully and it is legal data, this data will saved on the Chainlink data feed smart contract. And after this data is saved on the Chainlink data feed smart contract, it can be consumed by the user smart contract. or we usually call it a consumer smart contract. So as a developer, it is very easy for you to use the data provided by Chainlink data feed, because you only need to know the address of the pair of the asset, like your BTC/USDT or BTC/USDC, and you know this address. You just write this address into your smart contract and use the API of this smart contract, and then you call the function like a transmission, and you get the data from the smart contract deployed by the Chainlink. And actually, the data you fetched from this smart contract is actually aggregate a lot of the Oracle nodes in the decentralized Oracle network provided by Chainlink, and the data is coming from the thousands of the data sources, including some traditional data providers, centralized exchange, and other sources. So this data price is very safe and very transparent, and you get this data in a very decentralized manner. And the usage of the DON here is a common use case in the Chainlink. So in every different Chainlink services, the DON is always employed in this scenario. Okay, so the second service under the Chainlink data service is called a Chainlink function, and in the Chainlink function is a relatively a new service. We just released this service in the EastDC. I think in the August or the July this year, and it is under the beta. And if everyone else is interested in the Chainlink functions, you can just go to the website and make your address in the whitelist. So compared to the Chainlink data feed, the Chainlink functions is a service for the developers to get some unnormalized data, so customer data. So if you are building DeFi, you need a price of the asset. And if you want to build something like a Web3 version insurance, like a Web3 version gaming, Web3 version DAO, you actually need some customer data from the real world. For example, if you want to build a Web3 version for the flight delayed insurance, so if the flight or train is delayed, you just want to offer the payouts to the client. But how do you know if this flight is delayed or not? You need to get this data from the off-chain data providers. So in this scenario, the service you are going to need is the Chainlink functions. So as similarly as a Chainlink data feed, in the Chainlink functions, we also have a decentralized Oracle network here. And this DON is used to receive the request from the user. So this is an on-demand smart contract, the service. So only if the user sends the request, the DON will handle this request, maybe do some computation or get some API call. So the whole process is that the end user need to send this request through its user smart contract. And then the Chainlink smart contract will get this request and wrap everything necessary and all the data into a transaction. And this wrapped transaction will be emitted as an event. And if this event is emitted, and it can be detected by the DON. And you can write this request in the JavaScript file. So you maybe want to HTTPS GET or do the HTTPS post. You can write everything you want in the JavaScript file. And this JS file will be saved in the event. And the DON will get this JS file and run in its own environment. And every node under this decentralized Oracle network execute this JS file. It will get some data or computing some result. The nodes under the network will aggregate these results together and get a final report like before, and transmit or submit this final report to the Chainlink function smart contract. And the Chainlink functions will just verify this result and then fulfill the result back to the consumer smart contract. So as an end user, you just write your request and describe what you want DON to do in the JS file and submit this JS file. And this request will be detected. And after some blocks or after several seconds, you will get the result. So by using the Chainlink functions, you actually make your Web3 app just flexible or the powerful as any Web2 app has today, right? So in order to show how to use the Chainlink functions, we have a website called usechainlinkfunctions.com. And if you are interested in how to bridge the data from the Web2 world to the Web3, you can go to this website and learn more of the use cases. Okay, cool. So we just briefly overview the Chainlink data feed and Chainlink data services. And the reason of that is because I want everyone to learn the basic of the DON, the Decentralized Oracle Network. Now we will go to the focus today, the cross-chain service, the CCIP. The full name of the CCIP is the Cross-Chain Interoperability Protocol. And before we dive into the technology of the CCIP, I just want to ask everyone else to think about the future of the blockchain. So I will give 2 facts. The fact number 1 is the number of chains is increasing in recent years. So it may be very safe for someone to say, like, I only need an Ethereum mainnet, and I will build my dApp on the Ethereum mainnet, and everyone else will use this dApp on the Ethereum mainnet. But with the user is increasing in these years, it is impossible for everyone to use a dApp on the Ethereum mainnet because the gas fee is too high. You need to pay about $5 or $15 for a transaction, for a single transaction. So that is the reason we have a lot of the layer 2s. And actually, here is a website called Chainlist. So if you are a developer, you may heard about this website, and there are about 500 EVM chains on this website. So you can see that we have a large number of the chains, and the number of the chains is increasing year by year. So maybe in the future we will have thousands. We will have the total number. No one can give a total number of the chains. So the number of the chains is increasing. Maybe we will have the interoperability environment in the future and consider it as a necessity when we build our project. And the fact number 2 is that the liquidity fragmentation is increasing. So in the years before, we will have most of our asset on the Ethereum mainnet. But if you check the graph over here, I just get this graph from the DeFi Llama, and we have a lot of the different chains, and each color stands for a single chain, like Ethereum, Tron, BSC, the BNB chain, and Arbitrum. So the users are more willing to save their asset on the different blockchains, but not only on the Ethereum mainnet. And this can be reflected from this graph in the right hand. And you can see the percentage of the blue part, which represents the Ethereum mainnet, keep decreasing. And the number of the colors is increasing, and the percentage of the colors is also increasing. So you can see that the liquidity fragmentation is increasing in recent years. So I will give everyone a very interesting numbers. The total value bridged to now is 868 billion, and the token value bridged in the recent 12 months is like 115 billion. So the token value bridged in last year contribute the 68% of the total values. So that means the demand of the interoperability is increasing and increasing. So maybe in the future, when you build something in the blockchain, you will consider the cross-chain as a necessity. And it is a must-have feature in your dApp, because the user deposit their asset in the different chains. You want to reach the users in the different chains. You need to provide them a handle to just reach your smart contract, to interact with your smart contract. Okay, so when we talk about a cross-chain, what we are talking about? The cross-chain, maybe everyone will know that we want to cross one token from the chain A to chain B, from the source chain to the destination chain, and that is a kind of the cross-chain. But the ecosystem is growing, and we handle the more and more difficult logic, and we will need programmable token transfers. In this type of the cross-chain, we not only cross our tokens, but also cross some instructions following the token transfers. But if we abstract these 2 types of the cross-chain behind, we will see that if you can just move a arbitrary message from the source chain to destination chain, you can actually achieve these two types of the cross chain. So think about it, you want to cross a Bitcoin from the chain A to chain B. You will have a token pool on the chain A and you will have a token pool on the chain B. What you need to cross is just tell the chain B that you lock a BTC on the chain A and ask them to release a BTC on the chain B to your address. By doing this, you can achieve that the token is transferred, right? So if you can move this message, move this arbitrary message and cryptographic proof from the source chain to destination chain, you can do everything. Oh, I'm sorry. You can provide an interface of your app to the users on the blockchain that your dApp is not deployed, right? So the Chainlink CCIP is a kind of the protocol to do the messenger cross-chain. So in the Chainlink CCIP, as the other services provided by the Oracle, we have two parts: the on-chain part and the off-chain part. So because we are talking about the cross-chain, so we have a source chain and we have a destination chain, and we also have the off-chain infrastructure. So in order to cross one message from the source chain to the destination chain, we actually need to do the following steps. The first step is the commit. So you can see here the committing DOM. This is the decentralized Oracle network we talked before, and that is the same infrastructure used in the data feed and Chainlink functions. So the idea is that the sender need to send a request, send a message. He wants to cross from the source chain to the destination chain, and use the smart contract router to wrap this request and save that on the on-ramp. The on-ramp smart contract will be monitored by the committing DOM. And if there is any event emitted by the on-ramp smart contract, this request will be detected by the committing DOM, and the committing DOM will just move the cryptographic proof of this transaction from the source chain to the destination chain, the commit store. So the cryptographic proof of the transactions saved on the on-ramp will be crossed from the source chain to the destination chain. And that is step one, the commit. And after the commit is done, oh, I'm sorry, this should be somewhere else. So after the commit is done, we have the second row on the off-chain. It is called RMA, the Risk Management Network. The risk management network will just check the transactions, the cryptographic on the commit store and the transactions saved on the on-ramp to see if that can be proved. So if the verification is good and the transaction is legal, the RMN will just call the functions in the RMN smart contract to see like this transaction is good and it can be executed on the destination chain. And we call this process the blast. That means the transaction is blessed by the RMN, or you can say that the transaction is certified by the RMN. And after this step, the second step, we are coming to the third step, the most exciting one. The executing DOM will just execute whatever certified on the commit store and execute this transaction in the off-ramp. And maybe you just send a transaction to mint a new NFT on the destination chain. You want to do a swap in the Uniswap on the destination chain, or you want to move some funds from one address to another address on the destination chain, whatever you write in your transaction saved on the on-ramp. The executing DOM will just execute that on the destination chain, only if this transaction is certified or blessed by the RMN. So these are the three steps to move one transaction, move the message from the source chain to the destination chain. And the commit and execution part is actually the two steps, and that is totally separate, right? And this one is a recap for the whole process. So for this recap, maybe it's more easier to understand. We have these three rows in the off-chain. The first one is the committing DOM here, right? This one. And the second one is the risk management network, the RMN. And the next one, the last one is the executing DOM. So the whole process is like we talked before, the end user use the sender smart contract to send a message to the router. because this end user need to tell the CCIP which blockchain he want this transaction to be sent. So you need to input the chain selector and the messenger you want to cross in the router, and the router will wrap all this data together and send it to the on-ramp. And if this on-ramp receives the message, the details including the message, it will emit an event. And this event will be firstly detected by the committing DOM. And committing DOM, like we said before, do the step 1 commit. It will just commit the cryptographic proof on the off-ramp. And next one, when our risk management come to play, it will just check the cryptographic on the off-ramp and the transactions in the on-ramp to just blast it or curse it. I mean, certify it or don't certify it. And if this transaction is certified, the executing DOM will just execute this transaction in the off-ramp and use a router smart contract on the destination chain to just do the transaction to the receiver. And you can just move anything from the source chain to the destination chain. And even if the transaction you want to execute on the destination chain, it is also achievable. And you just wrapped all the bias data into your transaction, and this transaction can be executed by the decentralized network on the destination chain. So this is the whole process of the Chainlink CCIP. And with the Chainlink CCIP, what we can build on the future, actually we believe that the true innovation will only come from the community. But we can predict there might be this kind of the gap you can build with leverage of the Chainlink CCIP. The first one is like a cross-chain collateral. So, for most of the users of the blockchain, if you have a lot of the money on the blockchain, you may want to choose a very secure and decentralized network and save the most of your asset on the network. But you cannot do all the transactions on the mainnet Ethereum because it's too expensive. You may want to collateralize your asset on the Ethereum mainnet and get some liquidity like USDC or USDT on some lightweight layer 2. Maybe you just deposit 1 BTC on the Ethereum mainnet and get some USDT on the Polygon, or get some USDT on the other layer 2s. And there is one protocol has already achieved this. It is called Synthetic. That is a top project in the mirror asset. And except for the cross-chain collateralize, you can also do something like cross-chain governance. So, some very big project in the crypto, they will issue the tokens in the different blockchains, like AAVE, the RV. The RV will have their tokens in the different blockchain, but every token holders actually can make a proposal or vote a proposal is good or not. But if all the token holders reside on the different blockchains, how we can do that? You will have the cross-chain governance proposal smart contract on some blockchain and provide the interface of this blockchain. When I say interface, I mean the CCIP standard. And you can provide this standard in the different blockchain, and the user in the different blockchain will use this standard to send the transactions to make their proposal or vote for others' proposals, right? And also we can see like cross-chain trading or new kinds of the dApps or enterprise workflow. So one more word for the new kind of dApps. So in the last stage of the DeFi summer, maybe in the 2020, and you can see that we can just consider the different DeFi project on the blockchain as a primitive, as a defined Lego, and we can use a smart contract to combine all of this defined Lego and to create a new project, to create a new app. But with the CCIP, we can actually connect the different defined project in the different blockchain and connect them together. And maybe you can collateralize your asset on the chain A and get some liquidity on the chain B, and then save this liquidity in the protocol in the chain C and get the reward on the chain D, and that is possible. I mean, there are going to be a lot of opportunities for the developers to this kind of the new kinds of the dApps. Okay, So cool. I think I have already completed all the theoretical part. So we have 25 minutes left. So in this 25 minutes left, I'm going to do a demo with the leverage of the CCIP to just show how to use the Chainlink CCIP to send a cross-chain message from the chain A to chain B and mint a new NFT on the chain B. So the target is that I will provide a handle for the users to mint a NFT deployed on the Sapolia. And this user is this user would only need to send a transaction on the Fuji, right? And the step is that we build a USD721 smart contract on the destination chain, and we build a CCIP sender on the source chain, and we build a CCIP receiver on the destination chain, and then we will send a transaction from this sender and to call the USD721 smart contract on the receiver to get a new NFT. And without having any fund on the Ethereum Sapolia, you can just mint a new NFT from this NFT collection. And the reason I choose that Fuji is because that every time when you want to cross a messenger from the source chain to destination chain, you need to wait for the finality of the block. So maybe for the other layer 2 is take a little bit longer time, but you can use this on any other layer 2s, including the Polygon, and you can just deploy the sender on the Polygon and send this transaction from the Polygon to the Sapolia to mint a NFT without having any Sapolia ETH on the Sapolia network. Okay, cool. So let's start. The architecture we are going to use is like this one. So first one is the sender. We as an end user, we need to use a sender to send our message, and the messenger will be sent into the off ramp, right? The off ramp will be detected by the CCIP, and the CCIP will call the receiver on the destination chain, and the receiver will call the NFT, the USD721 smart contract, to mint a new NFT for the user. Okay, let's do this. So as I said before, if you have the laptop with you, I strongly encourage everyone to come to just code along with me and get a certificate when completed. So let me just. Okay, yeah. Oh, I'm sorry. I just opened my YouTube stream. Okay, I'm sorry. So let's continue. So if you have any questions, you just put it on the comments, and I will answer the questions after the demo. And I will put I'm sorry. I will put this one because I add some useful materials in this I just cannot put. So if you can just copy this one, the pad.result.net/p/November 4th workshop, you can see everything you need in the in this demo. Like before you start, you need to get some tokens, and these are the instructions. And we will do our demo following the steps on these instructions. Okay, so let's start. First, open the remix. So everyone knows the remix because you are from the developer community, and in the remix that is the online IDE. And I need to create a first of our smart contract called NFT smart contract. My NFT dot solidity. Okay, cool. So in this one, we just need to follow the instructions here. I have already write a very simple smart contract in my GitHub, and I just need to copy that smart contract and paste on the remix. Okay, copy everything here and paste in the remix. So let me check. Yeah, I'm on the, I should be on the Sapolia. Okay, so compile that. Yeah, when you see this green check mark, that makes you successfully compile this smart contract. Okay, this is the first smart contract, and we complete. Yeah, sorry, this one first, and secondly, I'm going to create this standard smart contract, and let me switch back to the remix. And where you can find this standard smart contract, go to the Chainlink documentation, docs.chain.link, go to this page. So this is official documentation for all the Chainlink products. So everything I talked to today, you can find on this documentation. And in the documentation, go to the, I think, a CCIP here, and then click this Getting Started. You will find some sample codes in the Getting Started. And we're going to the standard code. And we will scroll down and go to the standard code. Oh, this receiver. Standard code. So this one is a sample code for the standard we're going to use in our demo. So click this button on the top right end and to copy everything, and go back to the remix and create a second smart contract, call it standard.solidity. I'll paste it here. And in this smart contract, let me zoom in. Everyone can see that. In this smart contract, you can see here is a function called a send message. So you need to give the selector and the receiver address, and also you need to create this message. This message is going to be sent from the Avalanche Fuji to the Ethereum Sapolia in this demo. And I'm going to create a data we want to transfer. The data we want to transfer is a function call to call this safe mint under the USC centralized smart contract, right? So how we can call that? How we can do that? We create a bytes and memory, I think, and we give it a name called function call, and I use this one. In ABI is the environment variable provided by the Solidity, and you can use several functions in this environment variable. We call it encode with signature, and it will take two parameters. So the first one is the function name. We can go to this smart contract and copy the function name and put it here, safe mint. And the address is the first parameter. And the second one is the value we want to put into this function. The value should be the message.sender. So that means the sender who sent this transaction will just do a signature for this transaction, and we will just wrap this transaction and relay this transaction from the source chain to the destination chain. And after we get this, we copy these functions into this attribute. Yeah, because in the sample code, we just relay a string, but actually we want to relay a bytes, and compile that. Everything is good because we don't need a text. We remove that line, and in here, because we do not have a text. And also here, we don't want the text here, and compile that again. Oh, there is error. Yeah, that is because the comment. Compile that again. Yeah, we have already complete our standard smart contract. We complete this one. And next, I'm going to create this receiver smart contract on the remix. So like before, in the Chainlink documentation, there is a receiver code here. And we click this button like before to copy everything under the receiver code. and switch back to the remix, create the third smart contract called the receiver.solidity, and paste it here. So in this receiver smart contract, what we are going to do is to receive the message relayed by CCIP and then execute this transaction on the destination chain, right? So because we want to mint a NFT in the destination chain, and we need to first have a handle from this from the NFT. We need to import // and my NFT.solidity. And then we create a variable here called, what is the name of the smart contract? My token. Okay. So we create my token in the receiver. My token. And we give it a name called NFT. So before we start using this NFT, we need to pass the address of this NFT and to create a handle of that. So we just add a second parameter here, that is NFT address. And in the constructor, we just use NFT equals my token, and we give the NFT address here. So till now, we have our NFT instantiated, and we can use this NFT to call any functions in this smart contract. And next, we move to the CCIP receive. So this function is going to be called by the CCIP to put the message sent from the end user in the source chain to the destination chain in this smart contract. So when you see here, you can see there is this one, the EVM to any message. And in the receiver, there is any to EVM message. So this message is the same as this one. Okay, so for here, we can get the any to EVM message data we write before, and we will call this data to execute this transaction on the destination chain. And how we can do it, we can use the NFT address.nft.call and just call this one. Okay, so actually we have already complete the receiver code. Oh, I need to give it a flag to say if that is good or not, if that is successful or not. And we require the success. Okay, we want to promise this transaction is successful on the destination chain. And compile that again. Good. Everything is good. And yeah, we don't need that. So I will recap what I'm doing here. So first, we create an NFT smart contract. That is a very, very, very simple NFT smart contract. We only have one functions. I mean, except for the functions provided by this further smart contract, and we only write the safe mint to mint an NFT under this smart contract, and we have this sender, and we need to use this send message to send our message into the destination chain. And this message will be relayed by the CCIP. And in the receiver, we just receive this message and call this message, and call that to make the success, to make this NFT minting successful. And this is all we need to do with the Chainlink CCIP to send a cross-chain message. So next, we are going to deploy that to see if that it works. So first, in the remix in the environment, we need to use injected provider. And I will first deploy the smart contract on the Sapolia. So first one I want to deploy is my NFT. And click the deploy button, and the MetaMask popped up. Click confirm to deploy. And maybe we need to wait for like 10 seconds, I think. Okay, so we have our first smart contract here, the NFT smart contract. Have this one, the safe mint, right? And then we're going to deploy our second one, the receiver on the destination chain. To deploy the receiver, we can see that in the constructor here are two parameters. The first one is a router, and the second one is NFT address. NFT address is simple, and we can just copy that address and paste it here. But where we can find a router? So back to the Chainlink documentation and click supported network. We have all the configurations in this page for all the supported blockchains. So you can see we have Ethereum, Mainnet, Sepolia, and Optimism, and Avalanche, and Arbitrum, and Polygon, BNB chain, Base, and every blockchain you are going to use is a hackathon, I think. So for the Ethereum mainnet, we should use the Ethereum Sepolia. In the Ethereum Sepolia, you can see here we have the router address, we have the chain selector, and we will talk about later. Talk about what is chain selector later on. And first, we copy the router address on the Sepolia, and switch back to the remix and paste the address in the constructor and deploy that. MetaMask popped up, and click confirm to deploy the second smart contract. Okay, maybe 10 seconds as before. Yeah, the smart contract is deployed successfully. Now we have already completed these two, and we are going to deploy the third one, the sender one. And go back to the remix and switch to the sender, compile that. And don't forget to switch your MetaMask from the Sepolia to the Avalanche Fuji. And then in order to deploy that, we also have two parameters. The first one is the one we know where we can get the router. But for this time, we need to go to the Fuji and get the router address here. Got this one, and then paste the value here. And the second one is the link token address on that network. So we can find the link token address here, and then back to the remix and paste the address here, and then deploy. So for now, as you can see here, we are not deploying on the Ethereum Sepolia, but on the Avalanche Fuji, and click confirm to deploy that. Okay, let's see if that is successful. Yeah, confirm. So we have all these three smart contracts under the deployed smart contract, the NFT, the receiver, and the sender. So we are going to send our first cross-chain message in this with the help of the CCIP. So this function, the send message. And in order to send that, we need some parameters to be filled here. The first one is a destination chain selector. This parameter is used to tell the CCIP that which chain, what is the destination this transaction should be transferred. So because we want to transfer this transaction to the Sepolia, so we go to the Sepolia here, and remember that the chain selector. We need to get this string and use this string to put it here. I'm sorry, it is not a string, that number. And we also need a receiver smart contract address. Click this button, copy the address of the receiver, and then paste it here. So we have all the data we need to send a CCIP message. And then if I click this button to send a message, we will got I got this error, the gas estimation failed. That is because every time if you want to use any service of the Chainlink, you need to pay some fees for the Chainlink. And in order to pay this fee, I need to transfer some link token into the sender smart contract. So copy this smart contract and open the MetaMask here and click send and paste the address here. And just select the link. And I will give it 5 link tokens and click next. So I will transfer 5 link token from my wallet to the sender smart contract. Yeah, good. The transaction is confirmed. And then when I click that button again, there is no error, and a MetaMask pops up, and click confirm. So till now, we have already sent our first cross-chain message with the help of the CCIP. And when your transaction is sent successfully, you can click this one, the copy transaction ID, and check the status of this cross-chain message. Go to the CCIP.chain .chain.link. This is an explorer provided by Chainlink to check the status of the cross-chain transaction, and paste the transaction hash here. Click enter, and you can see here, right? This is a messenger ID. Let me zoom in. And the source chain transaction hash, because this messenger has not related to the destination chain yet, so not yet available, right? And the status is called a source finalized. That means the CCIP is just waiting for this block is finalized on the source chain to make that transaction cannot be reverted on the source chain. And after that, the CCIP will just relay the message from the source chain to destination chain and execute this transaction on the destination chain. And after that, you can see the source chain and the destination chain and the timestamp. And yeah, you nearly can find everything you need to know about this cross-chain message. And let me refresh that. We may need to wait for like 5 to 6 minutes for this cross-chain message is done. And if you use some other, the layer 2 or the mainnet of the Ethereum, you may need about 10 to 15 minutes. And I will first skip this here. Oh, that is a success. So that is very, very, very quick. So how we can check our transactions are successful or not? We can go to the OpenSea testnet, right? This is testnet.opensea.io, and I just use my wallet to sign a transaction to just sign in. And let me refresh. Oh, it is not displayed here. Okay, I think OpenSea needs some time to get this data and displayed on my profile. Oh, here it is. And you can see there is a new NFT shown in my profile. And when I click that one, you can find that this one is on the Sepolia chain. The Sepolia. And actually what the blockchain I send the transaction is not a Sepolia. So I send the transaction on the source chain, and one NFT on the destination chain is minted under my address. And on the destination chain, I don't have even one coin on my wallet, but I can do that. So by doing this, you can just provide an interface or a handle of your smart contract in another blockchain to allow the users in the different layer 2s and the blockchains to just interact with a smart contract deployed on your blockchain, right? So think about it, you can use that in the DeFi, in the gaming, or nearly every DApp. You can just use this method to provide the interface to the users in the different blockchain. Okay, so this is demo. So if you have successfully complete that, you can leave your address here, and I will just grant you a certificate that is a non-transferable NFT to your address. And if you have any questions, please leave here, and I will answer that. Even in the tomorrow or the late night, you can do whatever whenever you want, and I will answer your questions. Okay, let me move to my slides, and yeah, nearly everything is done. The coding is done, and yeah, I will spend last 1 minute to just share some useful information about the Chainlink developer community. The first one is the documentation, and you can see here the docs.chain.link. If you have any questions, if you want to find sample codes, just head to the docs.chain.link and to find everything you need. What I talked today can be found in this documentation. And also, if you have some technical questions, 2 options. So option 1, go to the Stack Overflow and post your question tagged with Chainlink, and we will answer that. Or go to our Discord and just post your questions on the Discord. You can find some technical support, or if you want to find some node operators, you have some questions about the Chainlink, you can post anything you want in the Discord. And if you want to contact with me, this is my contact information. Please find me on the Twitter, or we can call it X, or find me in the LinkedIn. And also you can find me on the Chainlink Discord. Okay, so I think everything is good, and this is pretty much what I want to talk today. And thanks for this opportunity. So yeah, thanks for your time coming to this workshop. Thank you very much. And hopefully you can make usage of the Chainlink to make your decentralized application more powerful.
Perfect. Thanks a lot, Frank. That was definitely very helpful. Very elaborate yet very crisp presentation that you had. So thanks for that. We have a few questions which Archana asked in the chat, which is regarding the general submission on DoraHacks. In the build tab, some projects are listed. Are these projects that are these the projects that have already been submitted to the hackathon? Yes. So since it's been a day or two since we kicked off the hackathon. Like I said, we've seen builds flow on the submission page. So in the build section that we have in DoraHacks, those are the projects which have already been submitted. However, you can always edit your build once you have submitted it during the course of the hackathon. Obviously, not after we've closed the submissions, but you can always go back and edit that. Um, and other projects built before the hackathon period acceptable? I asked because I noticed that some of the listed projects were built prior to the hackathon. Yes, definitely. If you've already been working on a project, if you've been building a if you've been building just a side project which you think is suitable, obviously keeping in mind the different tracks that we have on this hackathon, and also keeping in mind that it's been up to the requirements of the hackathon, you're always invited to submit that project. um, yeah, so that's it. We've put the links in the chat, in the YouTube chat. Docs.chain.link is your place to go, and then the Discord for the chain link. If you have any questions, any query related to the docs, related to the process that you'll be following, and also feel free to reach out to Frank if you have any question. um, you can also reach out to me if you have any general query about the DoraHacks platform or the submission. You can find me at Mishika251 on Twitter or Telegram. So yeah, definitely one of a very uh, great chance for all the builders to build. There's a lot of post hackathon support that all the partners and Polygon extends. So all the best to everyone who's building, and thanks a lot, Frank, for being with us here today.
Thank you. Thanks for your opportunity. I'm really excited for that. Thank you very much.
Thank you. All the best, everyone. Take care.
Good night, everyone. Bye.